Hi everyone, let's continue to review the graph of different common functions. The first functions, linear functions. So linear functions, we know they're like the lines, right? So this is the point, this is the slope-intercept form. So this is the slope-intercept form. M is the slope and B is the y-intercept. And this graph is a straight line. We also have the point slope form. Okay, if we know the point is like x0, y0, and we know the slope is m, the point slope form is y minus y0 equals m times x minus x0. Okay, and depending on the slope m, we know this guy m is positive, this line m is negative, horizontal line, the slope is 0. Vertical line, what happened to the slope? They're undefined. Okay, so here are the graphs for linear functions. For polynomials, an x to the m plus here I have a0. Okay, I should have a0 here. So where all the ai's, they are constant, they're called the coefficients of the functions, and n is the degrees of the function, and we require the leading coefficients is not 0. Okay, and we know a polynomial looks like that. Okay, next, power function. So if we have x to the power of a, and depending on the a values, we have different cases. First, when a is a integer, a positive integer, then what happened? Well, depending on whether the integer is an even integer or odd integer. So if n is an even integer, then it's like x squared, right? X squared, x to the 4th. So actually, all of them looks very similar, and they all pass through the points 1, 1, 0, 0, and minus 1, 1. Okay? And when x is greater than 1, you know, when the power increase, the function is above. Okay? So you can see x to the 4th is above x squared. Okay? And when x is between 0 to 1, and then the lower power is actually above, okay? So x squared is above x to the 4th when x is between 0 and 1, okay? And when n is odd, well, you see this picture? So we have x to the 3rd and x to the 5th. So they look very similar. They all pass through 1, 1, 0, 0, minus 1, and minus 1, okay? And when x is greater than 1, you can see x to the 5th is above x to the 3rd. But when x is between 0 and 1, x to the 3rd is greater than x to the 5th. Okay? And what happened when n is a rational number, okay? So if a is 1 over n, where n is a positive integer, then this guy, this is like square root of x. So square root of x here, when the root is even root, okay? So square root or fourth root, then they all looks very similar, okay? And your domain is greater or equal to 0, and your range is greater or equal to 0. And furthermore, if you can remember inverse function, x squared and square root of x, they are inverse functions. So they pass through the line y equals x, and they're like mirror image about that, right? So, but you can see here, because in order to have a inverse function, your function has to be 1 to 1. What's 1 to 1? 1 to 1 means one input corresponds to the one output. So that's why you can see here, x squared is not 1 to 1, so we have to restrict to a 1 to 1 piece that is greater or equal to 0. Okay, then this piece is 1 to 1, then we can take the mirror image across the line y equals x, so like that, to get our inverse function square root of x. Okay, and for x cubed, you can see x cubed, oh, it's 1 to 1. It's a 1 to 1 function, so we can take the mirror image across the line, y equals x, then we get this one. Okay? And so this is the f power roots. And then you can see for the even power roots, domain is 0 to infinity. Range is also 0 to infinity. For the odd power roots, range and domain, they are all minus infinity to infinity. So all real numbers. Okay? Alright, 1 over x. So this is a hyperbola, right? And we know that x cannot be 0. So the domain is x cannot be 0. The denominator cannot be 0. Okay. Next, rational functions. Rational functions, then we have the numerator and denominator. They are both polynomials. Okay. So what it's gonna look like? We require the denominator not equal to 0, right? So that's why the denominator, it cannot be 0. So when you solve for x squared minus 4 not equal to 0, how do you solve for it? You can factor as x plus 2, x minus 2. And you can see, well, it means x not equals to 2 and minus 2. And actually here you can see minus 2 and 2, we get 2 vertical asymptote here. So we will talk about more on vertical asymptotes in session 2.4. Okay? But it's continuous, and then but it will be discontinuous at the vertical asymptote. Okay. Trig functions. So we have 6 trig functions: sine, cosine, tangent, cotangent, secant, cosecant. So we know sine, cosine, they oscillate between -1 and 1. And the sine starts from 0. Cosine starts from 1, right? And then you draw the graph. How do you find tangent? Well, remember tangent is sine over cosine. So actually, even though we have 6 trig graphs, but you only need to know sine and cosine. And all the rest you can deduce from sine and cosine graph. Okay, so tangent is sine over cosine. So you can see at 0, you get 0 over 1 is 0. But at pi over 2 is like 1 over 0. It's not exactly 1 over 0. We know 1 over 0 is undefined. But 1 over some number that's getting close to 0. What is this guy? Think about it. 1 over 0.001. What is this guy? 1,000, right? So 1 over a number getting close to 0 will actually give us the bigger number. And 1 over 0 minus is minus infinity. So because 1 over negative 0.001 is going to be negative 1,000, right? So that's why here, when you approaching pi over 2 from the left, you can see your sine is 1, but your cosine is getting close to 0 from the right, positive, okay? So that's why 1 over 0 plus is infinity. That's why you get infinity. And when x goes to minus pi over 2 from the right, you can see your sine is 1, negative. Your sine is -1, and then your cosine is getting close to 0, but is above. So it's 0 plus. So -1 over 0 plus is gonna be minus infinity. So -1 over 0 plus is minus infinity. So you look at how many negative signs there. If 2 negative signs, that would be positive. 1 negative sign, that would be negative. Right? So you can see from the picture of sine and cosine, we can get the picture of tangent. And after we know the picture of tangent, we can know the picture of cotangent, because cotangent is 1 over tangent. So that's why when x is 0, 1 over 0 is infinity, right? So that's why we have positive infinity and minus infinity there. And 1 over, when x goes to power 2, 1 over infinity is 0. And also 1 over minus infinity is also 0. So that's why you can see it pass through 0 at pi over 2. And then next, how about secant? So cosecant, if you remember, cosecant is actually 1 over sine. What's 1 over sine? Well, you have your, so the blue dashed line is the sine. So here at pi over 2, 1 over 1 is 1. But when x goes to 0, the sine goes to 0. 1 over 0 plus is infinity. And here you're getting close to 0 from the right, positive. So that is also infinity. So it's like you flip it over, right? So and minus 1 is also minus 1. Then you flip it over, okay? So that is cosecant. How about secant? Well, secant is actually 1 over cosine. How do I remember those trig identities? I will teach you very soon, okay? After 1 minute or 2 minutes. Yes, then there's a quick way that you can memorize all the trig identities. Okay, so here, when x is 0, cosine 0 is 1. 1 over 1 is 1. When x goes to power 2, cosine goes to 0, but it's positive. That's why we have infinity there. So it's also like flip it over. Okay, so now you can see, just remember the graph of sine and cosine and all the rest you can deduce from the two. Alright, next we have the exponential functions and the logarithm functions. We know that they are inverse functions of each other, right? And so here I want to emphasize, okay, so let's look at exponential function. Alright, so if the base is greater than 1, then we have an increasing function. Okay, and if the base is 1, then 1 to the x is just 1. So we have a constant function. And if the base is less than 1, but it has to be greater than 0, because the base has to be a positive number, because it's a to the x, your x can be 1/2, then it's like square roots of a. You don't want to have square roots of a negative number. It will be a complex number, right? So that's why we require the base to be positive. But when the base is less than 1, then we have a decreasing function. So far so good, everybody? Okay, and how do we draw the natural log? The common picture we see is the exponential function e to the x. So it passed through the point 0, 1. Okay, this is e to the x. And you know, this is the line y equals x. We know e to the x and natural log of x, they are inverse functions. So that's why this point become now this point. And then our picture looks like that. So this is natural log of x. You can see it's also an increasing function. So far, so good, everybody. So important, do not confuse power functions and exponential functions. So power function is like x to the a, exponential function a to the x. Power function, the power is the constant. The variable is in the base. Exponential function, the base is a constant. The exponent is a variable x. Okay, so do not confuse them. Alright, let's continue. Okay, so here is the trick how to memorize the trig formulas. Okay, so can you see this hexagon? The way how we write it is just the natural way how we pronounce the 6 trig functions. We have sine, cosine, tangent, cotangent, secant, cosecant. So just write it down. They are the vertices of the hexagon. And then you put 1 in the middle. Okay, what's the power about this hexagon? Do you see we have 3 diagonals? Yeah, this one, this one, this one, and this one. So we have 3 diagonals. What's the special about the diagonals? The product of the 2 ends equals the middle one. So let's look at this one. The product of the 2 ends equals the middle one. So we have sine x times cosecant x equals 1. Right? That's why I know cosecant x is 1 over sine x. Let's look at this diagonal. The product of the 2 ends equals the middle one. So secant x times cosine x equals 1. So then now I know secant is 1 over cosine. The third diagonal, tangent times cotangent equals 1. So that's why here tangent times cotangent equals 1. So cotangent is 1 over tangent. Okay? And next, do you see there are 3 upside down triangles? Okay, so I call them upside down triangle because usually when you draw a triangle, you draw like this, right? But here, what we get, one of the vertices is pointing down, so I call them upside down triangles. So what's special about the upside down triangle? You get the sum of the square of the upper 2 corners equals the bottom square. Be careful, this is not the Pythagorean theorem. This is just a trick that helps us to memorize the formula. So this is not Pythagorean theorem. Okay? So this is not Pythagorean theorem. Alright, so be careful with that. So, let's look at the first upside down triangles. We have sine square plus cosine square equals 1, right? The second one, we have tangent square plus 1 square is 1 equals secant square. And the last triangle, we have 1 plus cotangent square equals cosecant square. You see, this hexagon help us to remember the 6 trig identities. Okay? Yeah, the Pythagorean theorems require the triangle must be a right angle triangle. And then you have A, B, C, then A squared plus B squared equals C squared. This trick, this picture is not Pythagorean theorem. It's just a trick help us to memorize the formula. Okay? So, remember those 6 trig identities together with the double angle formula. Then that's what we need in our course. Okay? So I hope if you cannot remember those, please remember them now. Okay? So what are the double angle formula? We have sine 2x equals 2 sine x cosine x. What's cosine 2x? Well, we have 2 formula for it. It can be 2 cosine square minus 1. It could be 1 minus 2 sine square. So it depends on which one you want to relate it with. Okay? And so if we use this guy and we can solve for cosine square. So cosine square is 1/2 plus 1/2 cosine 2x. And if we use this guy and we can solve for sine square. Well, sine square is 1/2 minus 1/2 cosine 2x. So we'll use this 2 a lot. Okay. Yeah, especially in calculus 2. Okay, so here are the trig identities and trig formulas that we need to know before we go to Calc 1 and Calc 2. Okay, of course, together with tangent. So tangent we know is sine and cosine. Okay, so then that's everything we need. Alright, so if you have any questions, feel free to email me. Have a nice day. Bye.